When a software application collapses under the weight of thousands of new users, the root cause is rarely a handful of typos or slow servers. The system fails because it was built on a flawed map of reality. Many developers start a new project by sketching out a series of user interface screens. They look at a dashboard, a login page, and a settings menu, and they assume the software is simply a collection of those flat visual spaces. Take a look at this diagram of an initial database setup. To power those simple screens, a developer will often create a single table with 3 basic columns: a title, a description, and a due date. For the first few weeks, everything operates smoothly. Users type in tasks, the screens update instantly, and the structure holds together perfectly. But a user interface is a temporary view, not a durable data structure. Confusing a screen layout with the actual shape of the business creates a fragile foundation that will buckle the moment the company grows. The breaking point always arrives in the form of completely normal feature requests. Users start asking to leave comments on tasks, and they want to attach PDF files. They need to assign the same task to 3 different people across 2 different departments. Watch our diagram. Instead of rethinking the system, the developer forces new features into the original design, cramming user comments and file histories into the exact same horizontal row. To search this landfill of nested text, the system must read massive blocks over and over. The immediate result is painful latency. Database queries that used to take milliseconds now take agonizing seconds to load. The developers start writing duplicated, messy logic in the front end, the back end, and the background workers just to keep the application running. Imagine a hospital system storing a doctor's appointment as a handwritten note tucked inside a patient's general text file. You would never be able to audit the doctor's schedule, track the room availability, or bill the insurance company accurately. When you try to force complex, ever-evolving information into a simple, static attribute, the entire architecture breaks under its own weight. To build software that scales, you have to think like a senior architect. That means identifying the primary nouns in your business, the actual living concepts that matter, and mapping exactly how they interact. We start by separating attributes from entities. An attribute is a static fact: a title, a due date, a color preference. These pieces of information have no independent life cycle. They exist entirely to describe something else. An entity is a meaningful, independent object. It has its own history, its own metadata, and its own rules. In this diagram, we perform the extraction process. We strip those complex, bloated fields out of the flat table and give them their own independent structural identity. A task, a user, and a comment now exist as distinct objects. These separate entities interact through strict cardinality rules. Cardinality simply describes the numerical relationship between items, like one user having many tasks, or many users belonging to many teams. We build connective tissue between these objects so data flows logically from one node to the next. True scalability comes from accurately mapping the business reality into a web of distinct entities, never from simply adding more columns to a database table. So before you write a single line of code, you have to answer a critical architectural question. How do you know definitively when a piece of data needs to become an independent entity? The first diagnostic test is time. Ask yourself if the data changes state, goes through a specific life cycle, or requires a dedicated audit trail. If you need to know who edited it and when, it is an entity. The second test is access. Does this piece of data require specific user permissions? If a manager is allowed to see a financial estimate, but a contractor is not, that information requires distinct visibility rules. It is an entity. Once you identify an entity, you establish data ownership. This means designating one clear, authoritative module in your codebase that dictates the rules for that entity, validates its truth, and controls how it updates. If a piece of data has a history, requires permissions, or demands strict ownership, and you treat it as a simple database field anyway, you guarantee a future of systemic duplication and stubborn bugs. Massive enterprise tools like Jira and Asana can handle millions of concurrent actions without failing. Their interfaces are fast, but their real power lies in their rich, interconnected domain models operating beneath the surface. Look at this network graph of an enterprise platform. You can see how an entity model absorbs change. They can bolt on entirely new features, like a time tracking module or an AI suggestion engine, and the network smoothly accepts new data points without requiring dangerous rewrites. This structural mindset is mandatory in the era of AI-assisted coding. Large language models will happily generate thousands of lines of chaotic, flat code if you, the human architect, fail to enforce strict boundaries up front. This split screen illustrates the golden rule of system design. You must define the exact shape, ownership, and relationship of your data before you ever touch a single line of interface code. Resilient software is not simply typed into existence. It is organically grown from an accurate, living map of reality.